of all these problem types, this is my least favorite. This is the 2012 AP Physics Mechanics 2. The first one I showed you where it was like, oh, you actually have to understand physics in order to understand those questions, which is good. The second one was about data analysis, which I can kind of get behind, but this one is it's just annoying from start to finish. So let's go through it. It's the design your own experiment. You are to perform an experiment investigating the conservation of mechanical energy involving the transformation from initial gravitational potential energy to translational kinetic energy. All right. You're given the equipment below, all the supports required to hold the equipment, and a lab table. On the list below, indicate so here's the thing. You just have the equipment, you got to skip because you have to design the experiment first, then go back. So it's outline a procedure for performing an experiment. Include a diagram, always include a diagram. Label the equipment. Include description of the measurements you would make and a symbol for each measurement. It's very particular what you have to do, so we're going to do B and then do A. And keep it simple, folks. Don't get complicated about it. So what I'm going to do is I'm just going to have a track. So here's a stand of something, right? So here is a stand. Here is a track. Here is a meter stick. Okay, the track, and I'm going to note the track is flat. And there is my cart. And here is my stopwatch. Okay, and so what am I going to do here? Well, looking at this, if we are looking at what's going on, I need to measure a couple of things. So if gravitational potential energy is mgh, right, I need to be able to measure m, I need to be able to measure h. So m is going to be measured. I'm going to use my my different, m, I'm going to use the electronic balance, right, and m is going to be measured, measure the cart. Actually, let's make this a little bit more straightforward. Kinetic energy 1/2 mv squared. So those are all the things that I have to measure here. So I have to measure the mass, I have to measure h, and I have to measure the final speed down here. So how am I going to do that? So 1, measure cart mass with balance. 2, measure initial height of cart with meter stick. 3, now here's the big tricky one. I need to know what the speed is here. Actually I won't put the meter stick here, but I'll say I have it. So here's my meter stick, right? I'm going to mark off 1 meter on the ground, okay? And then what I'm going to do is time how long on flat ground the object takes to cover 1 meter. All right? And so that's the doing about how I'm going to solve for that. So that's the description of all the measurements. So cart mass, this is m, initial height is h, and then this is going to be t, I'm going to call that t, and there we go. Those are all the measurements I'm going to make. And so now it says, give a detailed account of the calculations, right? So here we go. Now I'm going to do C. I'm going to say UG is equal to MGH. Plug in known mass and height. All right, done. Next, here's the thing. To find speed at end of ramp, do the average is equal to distance over time. where d is 1 meter and time is the time to cover the 1 meter. Okay, and that therefore then kinetic energy is equal to 1/2 mv f squared. This goes in there. So plug in V found in previous step. Okay, and that does it for everything. All right. Yep, I've told them how I'm calculating everything. Okay, great. So let me just go back and check all the things that I use: a track, a cart, a meter stick, a stopwatch, and that was that. There's other ways of doing this, folks. I could do, I have a pulley. I could do an Atwood's machine if I wanted to, using the meter stick and the stopwatch in order to find out times. But there it is. I think the thing that people screw up most about this is they actually do distance over time for this, but that only gets them the average velocity for this. You can still do that, folks, because you would say the acceleration is constant because the track is flat. The average velocity here is distance over time, but then you would have to say, therefore, V initial plus V final over 2 is equal to the average, and that could be used then to find that final velocity, which then is plugged into this equation. You just got to be super, super specific about it. So D, they then say, after your first trial, show that the energy increased during the experiment. Assuming you made no math errors, give it, okay, I pushed it when I started. Done. Therefore, work done, or positive work done on system to increase energy. Okay, E, the energy decreased. We did not account for the non-conservative work due to friction on track or straightaway. This work is negative, which decreases energy since Fk is opposite displacement. Okay, done. That problem is done. So it's just about designing a simple experiment. So if you see a list of stuff, don't get overwhelmed. You don't have to use it all. Design the experiment first, then go back. Just make sure that a lot of people assume they know the mass of things. You don't necessarily know the mass, so that's why the balance is there. But just don't get elaborate. Think of the equations. Think of what you need to calculate in order to plug into those equations, and then figure out some way in order to do that. And that's the design your own experiment lab. Actually, I will say one more thing about this. The most common error that people make in the design your own experiment labs is that velocity thing I mentioned, that an equation will require an instantaneous value of velocity, but all they are able to do is find out an average value of velocity in an interval. So make sure that you are thinking about that when you're doing these types of problems.